All right, let's take another example. This is number 26. And you remember definite intervals, what you have to do is find the antiderivative and then evaluate it to 2, evaluate 1, then take the difference. Okay, so we don't know how to integrate. Well, we do. Well, that was one of the first examples. But, so the question comes up, do you let u be this or do you let u be this? So we're going to do the indefinite integral first. And so what we have to do, remember, whatever you choose for your u, you're going to have to differentiate. Whatever you choose for your dv, you're going to have to integrate. So let's just try something. Let's let u be the w squared. And what's left over then has to be, we differentiate, so you get 2w cross multiplied by the dw. Just as an aside, my daughter used to, when she was growing up, when she was a little kid, she used to love dw, and I thought dw on that, what was that, Arthur? It was, really obnoxious. Anyway, so if we let our dv be the ln of w, we're going to have to integrate this, correct? And we did that on page 3. So we have, not sure why this is not, there we go. I think that's better, okay. So we did this already, so let's just use the result. So we've got what our v is from problem, page 3. I think this was one of the first problems we did. So now we put into our integration by parts. So we've got u and then v minus the integral of v du. And now I have the w squared in here. So we get minus 2w squared ln of w. Well, let's think about this. So I can break this up into two pieces. So I can do the minus the 2w squared. We can integrate that. But we end up with the same type of a thing that we started with right here. Is that bad or is that good? So here's what we're going to do. The integral shows up on both sides. So we're thinking of this as a big X problem and this as a big X problem. So we have made progress. Because now I have the unknown showing up here and I have it showing up here. So we can put these two together. So if we let x be this, so x is the unknown here, and then it shows up here. We can add to both sides. We get 3 of them. And then when we divide, what am I doing? Oh yeah, so we put 2/3 minus 1, which is minus 1/3. We divide both sides by 3, and voila, we have our answer. So there's a couple of things to consider here. One is, if you have stuff like just a plain polynomial, and you have like sines and cosines, you're probably going to let the u be the polynomial part, and the dv be the trigonometric part. And then when you have something like e to the thetas and cosine thetas, you'll remember, you had to do the integration by parts twice, and then you ended up with the unknown showing up on both sides. Here's another example where the unknown shows up on both sides. And so even though it looks like we have not made any progress, we really have. And You remember we were supposed to integrate from 1 to 2, so we have our antiderivative right here. We evaluate this at 2, we evaluate it at 1, we take the difference. So just substitute in a 2, a 2, a 2. That's what I've done here. Substitute in a 1, a 1, a 1. ln of 1, you remember, is 0. And so you just do some algebra and you come up with the following. Right here, 8/3 ln of 2 minus 7/9. So the whole idea behind the integration by parts is you're shifting a derivative off the u term onto the v term. Let's take another example. Oh, this looks lovely. Got close down. Oops. So this is number 32. How are we going to attack this? Now, what do we know? Well, I know how to differentiate the log, but now the problem would be this is like a u squared, so you're going to have to take 2 down, then the ln of x to the first, then you have to take a derivative of the ln. So I know how to take the derivative. Do I know how to take the integral, though, of the ln squared? This x to the 3 is going to have to come, upstairs and become x to the minus 3. Okay, so you have at least 2 choices. I say at least because sometimes there's going to be situations where you actually have several choices. More than just 2. So I can let this be my u, this be my dv, or I can let this be my dv, and this be my u. And so I can't tell you in general, follow this step and then this step and this step, and you get the right answer. You just have to try something, and you have to practice a lot of these. We could also do things like, and the reason I say at least 2 is because then you could also do the following. Pull the x cubed with the ln of x, or put an x squared with the ln of x and put the other one here. So you can see you have lots and lots and lots of choices. And so here's where you have to just try something. So remember, whatever you choose for your dv, you're going to be able to have to integrate it. And remember, there are situations where you might have to do integration by parts twice, and you hadn't ended up with a big X type of problem. So what I'm going to try is, I'm just going to try something. Okay, I'm going to let u be this, and I'm going to let dv be this. Okay, so if I let u be the ln, then when I differentiate this, the 2 is going to come down, and we're going to have an ln of x, and then I'm going to take the derivative of the ln of x, which is going to be 1 over x. So we're going to get 2 over x, and the ln of x, then I'm going to quote cross multiply to get the x on this side. And then your dv, we're going to let be 1 over x cubed dx, so you have to bring that upstairs. And when we integrate that, so you get minus 3 plus 1, which is minus 2, divided by negative 2. Forget about the concept of integration. We'll put that in at the very end if we need to. And so just do your simplification. So the x to the minus 2 comes down, 1 over 2x squared. So let's see if we've made any progress. Okay, so what we did was we started out, we're making the choice. This is my u, and this is my dv. So we have u times v minus the integral of v du. And now we have to ask ourselves the question, this is what we started with, this is where we're at. Have we made progress? Well, let's see, the 2's are going to cancel, the negative's going to become a plus 1. So let's put that all together. So what we now have is, let me go back here for a second. So if we go back to here, notice the x times x squared is going to be what? X cubed again, right? So what this means is we've gone from this to this. Have we made progress? Well, notice what's happened is the ln squared has become an ln of x. So this is not a big x type of problem. We have reduced the what? The power of the logarithm. So now this is really, you can think of this to be 1. So looks like we have made some progress, right? The ln of x squared has become an ln. So we've taken this term and reduced it by a power of 1. Now, I have to warn you, if this were, say, the square root of 1/2, now you'd have a problem because you're going to take the 1/2 power and make it into a minus 1/2 power. That's not going to help you, okay? And again, I can't give you some arbitrary set of instructions and algorithm that will always get you onto the right track. You just have to stop and look, see if it looks like you're making progress, and try something. So let's try it again. We made the choice, we let the u be the ln of x squared. Let's try this again. Our guess is that what's going to happen is this is going to what? Drop out. So let's see. If I let u be this, take the derivative of logarithm, remember it's 1 over x, and then just multiply by dx. I'm going to let the dv be this stuff right here. And remember, you have to bring the x cubed upstairs. It becomes x to the minus 3. Integrate, and you get this. So let's see now. So we now have, excuse me, so we let this be our u, this be our dv. So then we have u, v, minus the integral of this v, and then du, which is this guy. Now let's see what happens. Minus minus is plus. We can pull out the 1/2. Notice that there's no more logarithm here. We've gone from ln of x squared to ln to no more ln's. You can put the x's together. And we get this guy right here. And it's the same thing. You're going to have to bring the x cubed upstairs to get x to the minus 3. So that's going to give us this guy right here. Notice, no more integrals. So just do the arithmetic now. So minus 1/2 times 1/2 is minus 1/4. And then what you do is you put everything together again. So notice we had to do integration parts several times. Okay? And what was happening is, excuse me, this should be a squared. So we need to correct that in the notes. So what's happening here is integration by parts. You have to try something. And remember, what you're doing is you're shifting a derivative off the u term onto the v term. So here is the indefinite integral, and we had a definite integral. So then what you do is just basically what? Substitute in your limits of integration. So you have the antiderivative, you evaluate it at 2, you evaluate your antiderivative at 1, and you just take the difference. And so if you substitute in a 2, you get the ln of 2 squared, put in a 2 squared, put in a 2 squared, put in a 2, minus put in a 2. That's what I've done here. Put in the 1. Now when you go to put the 1, remember the ln of 1 is 0, so this drops out, this drops out. So you're just left with a what? Minus 1/4. And remember, you still have this minus in front, so you're going to subtract at minus a minus is going to be a plus. And so you just do the arithmetic. 4 times 4 is 16. That's where this guy comes from. And this is 8. And then this is also what? 8. So your final answer is this guy. So, integration by parts is a method to take your hard integral, hard to evaluate integral, and make it into something, quote, simpler. And the trick is to do what? You have to define a u and the dv, and whatever you come up with the dv, you better be able to integrate it, otherwise you're going to have a big problem. Remember, you may have to do this twice. I don't think in any of the homework you have to do it more than twice. I think twice is the most. So sometimes what you're going to have is a big X problem where you have the unknown showing up on both sides. And so what you do is you put them all, you call them a big X, and you put them all together, and you're done. Great. Let's move on to the next section.